Good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening, children. Yeah, we have to continue from the 8th one, correct? We finished till 7 yesterday. Am I right?
Yes, ma'am.
Yeah. Okay. So let's see the information given in question number 8. In a right triangle ABC. So you can see the figure given below here. Here, this figure. In a right triangle ABC, right angle at C. So right angle at C. You can see here. In a right triangle ABC, right angle at C. So right angle at C. M is the midpoint of hypotenuse AB. So AB is the hypotenuse and M is the midpoint of the hypotenuse AB. Because ABC is a right triangle. ABC is a right triangle and it's right angled at C. So AB is the hypotenuse and M is the midpoint of the hypotenuse. That means AM is equal to MB because M is the midpoint of AB. So AM is equal to MB. Why is AB the hypotenuse? Because ACB is a right triangle, right angled at C. So the side opposite of the right angle is the hypotenuse. So AB is the hypotenuse in triangle ABC. M is the midpoint of the hypotenuse AB, which means AM is equal to MB. So you can see that here. M is the midpoint of AB. That means AM is equal to MB or AM is equal to BM. And angle ACB is 90 because it's given right angle at C. So angle ACB is 90. Given angle ACB is 90. Whatever information is given, you need to write it under this heading given. Right angled at C. So angle ACB is 90 degrees. M is the midpoint of AB. So M is the midpoint of AB, meaning AM is equal to MB. AM is equal to MB. So that's given. C is joined to M and produced to D. So it's like as if there is only this triangle first, See, it's like there's only this triangle first, ACB. We only have this triangle ACB, ACB. So we know that M is the midpoint of AB. Now C is joined to M. So let's join C and M. C is joined to M and produced to a point D such that DM is equal to CM. Now C is joined to M and it's produced to a point D. It's produced to a point D such that CM is equal to DM. It's C is joined to M. So like the C is joined to M and it's produced to a point D. It's produced to a point D such that CM is equal to DM. CM is equal to DM. So it's given that CM is equal to DM or DM is equal to CM. So see here, such that DM is equal to CM. Point D is joined to the point B. Point D, this point B, this point D is joined to the point B. Show that that's how you have this figure. That's how you have this figure. So C is joined to M and produced to D such that DM is equal to CM. And then D is joined to B. Okay. So with this information given to us, we need to show the triangle AMC. AMC, this one, is congruent to triangle BMD. BMD, this one. We need to show that these two triangles are congruent to each other. So you know what is to be written in given, and then to prove all these four things, whatever is to be proved, all these four. So to prove 1, 2, 3, and 4. Okay, this is the figure given to us in the question. This figure is given to us in the question. All right, so given to prove. We don't have any construction here. So there is no heading construction. So directly the proof. So I have taken up this figure here. This is the figure here with the numbers. I've numbered the angles, so you can see that here. And then I've shown these two triangles separately. That is, we have to show that this triangle is congruent to this triangle. So here I've shown the two triangles separately. These two triangles separately. These two triangles. We have to show that AMC, this triangle, is congruent to BMD, this triangle, BMD. I've just taken them separately, AMC and BMD. Sorry. All right. So I hope we all understand from this figure. I've taken this triangle AMC, this triangle AMC with angles 1, 3, and 5. You can see here. And this triangle BMD with the angles 2, 4, and 6. You can see here. These two triangles. Now we'll have to show that these two triangles are congruent to each other. Okay. Now what do we have in the two triangles AMC and BMD? In the triangles AMC and BMD, we know that AM of the first triangle. See, AM is the side of the first triangle, AMC. Okay. We know that AM of the first triangle is equal to BM of the second triangle. Because it's given, AM is equal to BM is given. AM is the side of this triangle. BM is the side of this triangle. See a BM, AM. AM of the first triangle is equal to BM of the second triangle, given. Then angle 1 is equal to angle 2, vertically opposite angle. See here, in this triangle, angle 1. In this triangle, angle 2. Angle 1 of the first triangle is equal to angle 2 of the second triangle. Vertically opposite angles are equal. And then CM of the first triangle, CM of the first triangle is equal to DM of the second triangle. See, CM is the side of this triangle. DM is the side of this triangle. These are the two triangles which we have to prove are congruent. So CM of this triangle is equal to DM of this triangle. How do you know that? It's given. CM is equal to DM is given. So that makes side angle side. See here, two sides included angle. See here, we have mentioned. Sorry, children, there's somebody at the door. I'll just come back. I'm so sorry. Yes, children. So now look at these three things. AM, CM, angle 1. AM, CM, angle 1. Clearly, AM and CM are the arms of angle 1. AM and CM are the arms of angle 1. See here, AM, CM, angle 1 of the first triangle. So this is angle 1, AM and CM. So AM and CM are the arms of angle 1. And the other triangle, BM, DM and angle 2. BM, DM and angle 2. You can see it here also. BM, DM and angle 2. Clearly, BM and DM are the arms of angle 2. So that is SAS. Two sides included angle. Two sides included angle. So by SAS congruence criterion, the two triangles are congruent to each other. Now you know how to write the order, so I'm not talking about that. The two triangles are congruent. So that's what we have to show first. Okay, we're done with this. Next, we'll have to show that DBC is a right angle. So we know that this angle is 90 degrees. We know that angle ACB is 90. This one is 90. We are not given that this is 90. It may look like a right triangle, but you cannot assume 90 degrees there. Okay, so this is given to us. This is 90 is given to us. Now we'll have to prove that this angle is also 90 degrees. DBC is a right angle. DBC, this one is a right angle. So how can you prove that this is 90? See, we know that this is 90. So this can be 90 if they are co-interior angles. If you can prove that these two are co-interior angles, this angle, if you can prove that these two are co-interior angles, then we know that co-interior angles are supplementary. All right, So when a co-interior angles, no, I didn't put it correctly, children. These are co-interior angles. I'm sorry, I'll just come again. Meaning I was distracted. I just blurted something. Yeah. I should have told you like this. These two angles are co-interior angles made by the transversal BC with the lines BD and AC. These two angles are co-interior angles. Here we have two lines here. We have two lines here. Or we have a transversal here. And this angle are co-interior angles made by the transversal BC with the lines BD and AC. Now, when are they supplementary? If BD is parallel to AC. When are they supplementary? If these two lines are parallel, they are already co-interior angles. These are already co-interior angles. They are supplementary if you prove that this angle, if you prove that this line is parallel to this line, then these angles are supplementary because they're already co-interior angles. Now they're just co-interior angles. If you prove that the lines are parallel, then they are supplementary. So we are going to prove that these two lines are parallel to one another. We're going to prove that these two lines are parallel to one another. Now, how do you prove that two lines are parallel? Two lines are parallel if a pair of alternate interior angles are equal. Two lines are parallel if a pair of corresponding angles are equal. Two lines are parallel if co-interior angles are supplementary. So now, since we have proved that these two triangles are congruent to each other, or we have proved that this triangle is congruent to this triangle. So that means the corresponding angles will be equal. The corresponding angles will be equal because when two triangles are congruent, the corresponding parts of congruent triangles are also congruent. All right, now look at the names AMC, BMD. So angle A of the first triangle is equal to angle B of the second triangle, which is angle A of the first triangle, this one, is equal to angle B of the second triangle, this one. That is angle 3 is equal to angle 4. Now you might say that already 3 and 4 are equal, they are alternate angles. They are alternate angles, but we don't know that they are equal. Now they are equal because the triangles are congruent. See, they are already alternate angles, I agree. Some line, transversal, some line. Okay, so 3 and 4 are already alternate interior angles. But now they are equal. Why are they equal? They are equal because they are the corresponding parts or the corresponding angles of two congruent triangles. See here, angle A of the first triangle is equal to B of the second triangle. So this is A of the first triangle. This is B of the second triangle. So these two are equal. M of the first triangle is equal to M of the second. So see here, I'll mark here. This angle is equal to this angle. Then M of the two triangles are equal. That is, this is M of the first triangle. This is M of the second triangle. This is M of the first triangle. This is M of the second triangle. Then C is equal to D. That is angle C. C of the first triangle is equal to D of the second triangle. This one. Okay, that means this angle. This is C of the first triangle. Angle C of the first. See here, the third vertex. C of the first triangle is equal to D of the second triangle. This one. Okay. So like this. We already know that these are vertically opposite angles, they're equal, but this is new for us. Angle 3 is equal to angle 4 and angle 3 is equal to angle 4. Angle 5 is equal to angle 6 is new to us. We did not know that earlier. Earlier, we knew that they are alternate interior angles, but we did not know that they are equal. Now that we have proved that the two triangles are congruent to each other, the corresponding angles of the two congruent triangles will also be equal. So angle 3 and angle 4 are the corresponding angles, not parallel lines, transversal corresponding angles, not that. Not the corresponding angles which we use with respect to two parallel lines intersected by a transversal, not that corresponding. This is corresponding in terms of congruent triangles. So now that these two triangles are congruent, angle 3 of the first triangle corresponds to angle 4 of the second triangle. Angle 5 of the first triangle corresponds to angle 6 of the second triangle. So angle 3 is equal to angle 4 CPCT. Or you can say angle 5 is equal to angle 6 CPCT. Take any one information. You don't need both. Any one you can write. So supposing you write angle 3 is equal to angle 4. But so why 3 is equal to 4? CPCT. CPCT. But angle 3 and 4, see here, but angle 3 and 4 are a pair of alternate interior angles made by the transversal AB with the lines AC and BD, with the lines AC and BD, and are equal. The alternate angles are equal. They are alternate angles, but now they're equal because CPCT, they're equal. Therefore, AC is parallel to BD. Therefore, AC is parallel to BD. Or so this figure is actually not, I won't say not relevant. You can also, this for this one, this is enough. I've just put this figure here because you can also write angle 5 is equal to angle 6 CPCT. You can also write angle 5 is equal to angle 6 CPCT. But angle 5 and angle 6 are a pair of alternate interior angles made by the transversal CD with the lines AB with the lines AC and BD, and are equal. So this figure, I hope you understand now. You understand why I put this figure here? You can also write angle 5 is equal to angle 6 CPCT. Then you should show this figure. Angle 5 is equal to angle 6 CPCT. But angle 5 and angle 6 are a pair of alternate angles made by the transversal CD with the lines AC and BD and are equal. Therefore, AC is parallel to BD. So for that sake. Now for what I have written here, this figure is not needed. Okay. So we proved that AC is parallel to BD. So now take up this figure. See, we have proved that AC is parallel to BD. Now you understand what I've taken up. AC is parallel to BD. I've taken up only this. So we proved that AC is parallel to BD. Now this is 90 degrees. Now AC is parallel to BD and BC is the transversal. BC is the transversal. So we know that this angle plus this angle is 180. Earlier we only knew that these two angles are co-interior angles, but we did not know that they are supplementary because the lines are not parallel. Now the lines are parallel, so they are supplementary. So the angles are supplementary. Co-interior angles are supplementary because the lines are parallel. And since this angle is 90 degrees, this is also 90. So that's what you see here. The sum of these two angles is 180. Since this is 90, DBC is also 90 degrees. And finally, we have to, not finally, sorry, we finished the first and second one. Now we'll have to show that DBC is congruent to ACB. DBC, the full triangle, this one, DBC, this one. This is a right triangle, this is also a right triangle. Now, because we proved that this 90, we have proved that DBC is 90, DBC is 90. ACB was already 90. ACB is a right triangle. Now that this is 90 degrees, DBC is also a right triangle. So both are right triangles. You can see here DBC. We'll have to show that. You'll have to show that DBC is congruent to ACB. So I've taken up only those two pieces here. From this whole figure, I've taken those two pieces, DBC and ACB here. And I've marked whatever we have, we know that this is 90 and this is 90. And this is the common side. This is the common side. Both the triangles stand on the same base BC. Both the triangles stand on the same base BC. All right, so that's what I've marked here, equal. Equal because it's the common base. All right, and then we already know, since these two triangles are congruent, see here, AC is equal to BD, CPCT. The corresponding sides of congruent triangles are also equal. So AC, in this triangle AMC, AC is equal to in the other triangle BMD, BD. BMD. See, this is BMD, BD. So this side is equal to this side, CPCTC, from the congruency of these two triangles. Okay, so that's what I've marked here. So in these two, I've shown these two triangles here, and both are right triangles. This is the common base. BC is you can see the main figure here. Both the triangles stand on the same base BC. Okay, and then I've marked DB is equal to AC because DB is equal to AC here. From the congruency of these two triangles, AC is equal to BD, CPCT. So now we have SAS here, two sides include angle, two sides included angle, two sides included angle. So SAS rule, the two triangles are congruent. So name the triangles DBC and ACB. So you know that DB is equal to AC, CPCT from the congruency of these two triangles. Then this angle is 90, this is also 90. BC is equal to BC, common side. So the two triangles are congruent by SAS rule. Okay, the two triangles are congruent by SAS rule. This one is over. DBC congruent to ACB, this we are done. See here. Okay. Furthermore, we'll have to show that CM is equal to half of AB. CM is equal to half of AB. So now see here, CM AB. We have CM and AB. So what goes with AB? AB, where is AB? AB. AB. So we need AB here in the result. Okay, we need AB here in the result. So actually, now that these two triangles are congruent, AB is equal to DC or CD, whatever. Okay, these two triangles are congruent. These two triangles are congruent. So see here, AB is equal to DC or CD. See, when you say DC, this is the side. When you say CD, it's the same side. When you name the triangle like DCB, CDB, that is different. When you use the congruency symbol, and instead of DCB, triangle DCB, if you write CDB, that is different. But when it comes to representing a side, AB is the same as BA. Both are the same because it represents the same side. So for side AB, BA, both are the same. But when your name, once you prove that the triangles are congruent, then instead of ABC, if you write BAC, if you say AB and BA are the same, so instead of ABC, I wrote BAC. No, no, no. When you're naming the triangles, once they're congruent, when you name the triangles, you should name them in the correct order. If it is ABC, it is ABC only. BAC is different. It's the same triangle, but the way you name it is important. You all know it now, by now. But when it is side, it's okay. AB, BA, with, see, like it represents the same side. This is AB. The same thing as BA. So for side, it's okay, not for naming a triangle. Now, since we have AB in the result here, so AB is equal to what, children? AB is equal to DC. So that's what I've written here. AB is equal, you can write DC also if you want. AB is equal to DC. Okay, AB is equal to DC, CPCT. Because these two triangles are congruent, AB is equal to, AB is equal to CD, CPCT. Why you'll wonder why you have to write only this information? That's because in this result, CM we don't have anywhere here. Anywhere here we don't have CM, but you have AB. No, we have AB here, AB. So we are writing that information because in the result we have AB here. So we are trying to write AB is equal to DC. AB is equal to DC. Then come back to the result. You have half AB here, half AB. So we are multiplying both the sides by half, or you're dividing both the sides by 2. It's the same. Multiplying by half, dividing by 2, both are the same. Dividing by 2 is the same as multiplying by half. So first we write the result AB is equal to CD, and then we multiply both the sides by half, or you're dividing both the sides by 2, whatever. So half CD is equal to half AB. When two things are equal, their halves are also equal. Halves of equals are also equal. Halves of equals are also equal. So half CD is equal to half AB. Now have this half AB as it is, because see here, there is no change. Half AB is as it is. So write half AB as it is. What is half of CD? Half of CD. This is CD. This CD. Half of CD. Half of CD is because it's given that DM is equal to CM. DM is equal to CM. So half of the CD is CM or DM. Anything you can write. See here. DM is equal to CM. It's given here. DM is equal to CM. It's given. DM is equal to CM. That means half of CD. Half of CD, you can write any half. You can write CM or DM. But what you have here, CM. So half of CD is nothing but CM. Instead of half of CD, you're writing it's half CM. Or you can write DM also, depending on what you have in the result. So half of CD, what is half of CD? CM is equal to this. We don't write half of AB because half AB is as it is in the result. So first we write AB is equal to DC. AB is equal to DC or CD. Then we multiply both the sides by half. So we get half CD is equal to half AB. Half AB we write as it is because that is there in the result. But this half CD is not in the result. So for half CD, you have to write something else. Something else is equivalent. You should write an equivalent for half CD. So for half CD, you can write DM or CM. Both are, half of CD. So what is here CM? So you write CM is equal to half AB. Yes, children, if you have any questions, you can ask me.
Ma'am?
Yeah.
Ma'am, can you please explain the last part alone?
Sure. Yeah. Last part. Can you be more specific, ma'am? Which one? This one. Huh? Last part is the third subdivision or the fourth subdivision?
Fourth subdivision, ma'am.
Fourth one. Huh? Okay. This one.
Yes, ma'am.
Okay. So see the result. What do you have in the result? CM is equal to half of AB. CM is equal to half of AB. So I'm trying to get, now we are not writing DB is equal to AC. We are not writing DB is equal to AC. Why? Because we don't have anything. We don't have DB. We don't have AC also. So since we have AB here, we're trying to get a result which has AB. So see, there is AB here. There's AB here also in the result. So AB is equal to what? AB is equal to DC. So we start with that. DC is equal to AB. We start with that. Then we see how the result looks. We have half AB. So since we have half AB, we multiply both the sides by half. So multiplying both the sides by half, half into DC is equal to half into AB. We are multiplying both the sides by half. You can do any, you should do the same action on both the sides. When you're working with an equation, you should do the same action on both the sides. So half DC is equal to half AB. Now, what is, don't write anything for half AB, write it as it is, half AB. Now for half of DC, what is half of DC? Half of DC, see, this is DC, this is DC. And since DM is equal to MC, both these two are equal. DM is equal to MC. So half of DC is equal to DM. Half of DC can be DM, or half of DC can be CM. You write any one. Instead of half DC, you can write DM, or instead of half DC, you can write CM. But what do you have in the result? CM. So instead of half of DC, instead of writing half DC, we write its equivalent CM. So we get the result CM is equal to half AB. Yeah, you can ask me specifically now what you don't understand. If it's clear, fine.
It's clear, ma'am.
Okay. Anybody else? Please ask me. Understand, children?
Yes, ma'am.
How many of you have learned this chapter in school?
No doubts, ma'am.
Yeah, Sindhu, okay, Montfort. Netra and Danya, you have not learned this in school, right?
Yes, ma'am.
Netra has not learned. What about Danya? What did you say?
Ma'am, they completed, ma'am.
Oh, completed. Very good. I'll let you know. Now, till example 8, I had already shared the slides with you, meaning I'd asked you to take screenshots of the slides and you were supposed to complete it. So which is why I did not give you time to write in the class now. All right, so please finish it if you have not finished. Yeah. So here E and F, this is the next exercise, NCERT. E and F are respectively the midpoints of the equal sides AB and AC. So see here, so much information is there. Equal sides AB and AC. So that means in this figure, AB is equal to AC. That means ABC is an isosceles triangle. ABC is an isosceles triangle. AB is equal to AC. ABC is an isosceles triangle. So here we have a property. In an isosceles triangle, Here. If these two sides are equal, the angles opposite to them are also equal. Which is the angle opposite to this side? This angle. Just a second, children. Yes, children. So I was telling you that in a triangle, when two sides are equal, in a triangle, when two sides are equal, the angles opposite to them are also equal. So now, if these two sides are equal, the angle opposite to this side is this angle. The angle opposite to this side is this angle. In simple words, like see here, these two equal sides, where do they meet? That is, which is the angle included between these two sides, this angle, no? Leave that angle. The remaining two angles will be equal. So I'll tell you again. I'll tell you. Now, supposing these two sides are equal. Supposing these two sides are equal. Supposing these two sides are equal. Now, these two sides contain this angle. This side and this side contain this angle. This angle. Leave that angle. These two angles are equal. These two angles will be equal. Now, supposing these two sides are equal. Now, this side and this side contain this angle. Include this angle. See here. This side and this side, they meet here. Side, they meet here. They meet here. Leave that angle. The remaining two angles will be equal. The remaining two angles will be equal. The theorem is in a triangle, when two sides are equal, the angles opposite to them are also equal. So if these two sides are equal, the angle opposite to this side is this angle. The angle opposite to this side is this angle. Opposite to this side is this angle. Opposite to this side is this angle. So if these two sides are equal, these two angles are equal. So similarly, if this side is equal to this side, opposite to this side is this angle. 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 So if these two sides are equal, these two angles are equal. Similarly, the converse is also true. The converse is also true. If two angles are equal, the sides opposite them are also equal. The side opposite to this angle is this. So now see, these two angles contain this side. Leave that side. The remaining two sides will be equal. In a triangle, if two angles are equal, now this angle and this angle, they contain this side. They contain this side. This angle and this angle, they contain this side. But leave that side. The remaining two sides are equal. The remaining two sides will be equal. That is, in a triangle, when two angles are equal, the sides opposite to them are also equal. Opposite of this angle is this side. Opposite of this angle is this side. If this angle is equal to this angle, opposite of this angle is this side. Opposite of this angle is this side. These two sides will be equal. So in a triangle, when two sides are equal, the angles opposite to them are also equal. Conversely, in a triangle, when two angles are equal, the sides opposite to them will also be equal. Okay, so here it's given that E and F are respectively the midpoints of the equal sides. So AB and AC are equal sides. E is the midpoint of AB, F is the midpoint of AC. Now we need to show that BF is equal to BF is equal to CE. BF is equal to CE, which is BF. This is BF is equal to CE. Yeah. So now tell me, children, which to get this result BF is equal to CE, you need to take a triangle which has BF as a side, and you need to take another triangle which has CE as a side. Name the triangles. Yeah, try. To show that BF is equal to CE, you must take one triangle which has BF as a side, and you must take another triangle which has CE as a side. Yeah. Tell me one triangle which has BF as a side.
Ma'am, triangle CBF.
CBF. Okay. Triangle CBF has BF. And another triangle which has CE.
Triangle BEC.
Triangle CE.
B.
B. Very good. CEB. So this triangle has BF. This triangle has CE as a side. Correct. The triangles below, that is, you're talking about this triangle and this triangle. These two triangles. This is EBC. This is FBC. These two triangles. CBF. This is CBF. This is the first triangle. And CEB. This one, the second triangle. Correct. Now, tell me three equalities in these two triangles.
Ma'am, BC is common, ma'am.
BC is common. Because both the triangles stand on the same base BC. So BC is equal to BC. Correct. Yeah, next. See, let me tell you like this. 1 minute. Now, to show that BF is equal to CE, you can say in triangle EBC and triangle FBC. Or you can also take up which two triangles. There is another, there is another triangle which has BF, another triangle which has CE. Which is that?
Ma'am, in triangle ABF and ACE, ma'am.
Very good, AC. So you can take any one. You can take any pair. You can take these two or these two. So these two, this triangle has a CE as a side. This triangle has BF as a side. This triangle has BF. This triangle has CE. So you can take up this triangle on the top. See, this triangle has BF. This triangle and this triangle which has CE. This triangle which has CE. You can take up these two triangles, or you can take up this triangle below, which has CE as a side, and this triangle below, which has BF as a side. BF as a side. You can take up any pair. Oh my God. So the triangles above, I'm sorry, I wrote below first. No? Okay. So the two triangles below are in triangle which has BF, CBF has BF. And which one has CE? BCE has CE. Yeah. And then here, which triangle has BF, ABF, and which triangle has CE, ACE. Yeah, now tell me three pairs of equalities here. They must be parts of these two triangles. You know, a triangle has three sides and 3 angles. So what you say must be the first one should be of this triangle, the second one should be of this triangle, not some two equal things. Yeah, start. Yes, yes.
BC is common in
BC is
both
common.
triangles.
Correct. BC. In this one, BC is equal to BC, common side. Correct. Next.
Ma'am,
Yeah, tell me.
EB is equal to CF, ma'am.
EB is equal to C. So that is CF of this triangle is equal to 1 minute. What?
BE of
Sorry. What did you say? CF is equal to BE.
B
Correct.
because they are
Okay.
midpoints, no, they divide half.
Correct. That's because it's given that AB. We are given that AC is equal to AB. Correct. AC is equal to AB. Correct. So half of AC will be equal to half of AB. What is half of AC? Because F is the midpoint. 1 second. So we know that AC is equal to AB. It's given to us in the question. So half of AC will be equal to half of AB. So half of AC is AF or CF. Half of AC because F is the midpoint. So it's AC, AF or CF. So you can take CF here is equal to half of AB. What is half of AB? What are the two halves of AB, children?
EB and BE.
Yeah.
Correct. AE and BE. You can write anything. So we are writing BE here. So like that, you get CF is equal to BE. CF is equal to BE. So two things are equal. So their halves are also equal. And then when you find their halves, you can get CF and BE. Very good. Then one more. Yes, children, one more. Yes, children. Shall I say? Shall I say, children?
Just a minute.
Yes, ma'am.
Okay, Raja's telling just a minute now. All right. Good, good. Think. No. All right. So now look at the triangle, children. Look at the triangle ABC. ABC. Okay, so we know that these two sides are equal. So by the theorem, when two sides are equal, the angles opposite to them are also equal. So these two angles are equal. Now this angle is in, see this angle, I'm talking about this angle, children. This angle is in triangle CBF. See here, look at triangle CBF. Can you see this angle?
Yes, ma'am.
Yeah. Now look at the other triangle. See, it's the same triangle ABC, same triangle ABC. These two sides are equal, so these two angles are equal. So this angle C is equal to this angle B, which is the other. See here, there is E here, midpoint E. When you join this here, in the other triangle, this is the other triangle CBE. CBE has angle B in it. See here, see here, CBF. This is the first triangle CBF. This one CBF, and this is the second triangle BCE. This one. See here, children. The CBF is here. This BCE is here. BCE. See here, we know that these two angles are equal. This angle is in this first triangle, and this angle is in the second triangle. See here. Yes or no?
Yes, ma'am.
So angle
Yes,
C in the first triangle is equal to angle B in the second triangle, because AB is equal to AC. Because AB is equal to AC, isosceles triangle. It's called the isosceles triangle property. Angles opposite to equal sides are equal. Angles opposite to equal sides are equal. So this angle, see, we know that these two angles are equal. This angle is in this triangle CBF, and this angle is in this triangle EBC. CBF, EBC, this one, these two triangles. So how do you know that this angle of the first triangle is equal to this angle of the second triangle? Because the two sides are equal. AB is equal to AC, isosceles triangle property. So what rule it makes? What rule it makes? SAS. Two sides include, yeah, two sides include angle. Two sides include angle. See here, the first triangle, you know, that is CBF. CBF, don't see this one. Don't see this one. Okay, see the triangle CBF. This is the triangle CBF. CBF. We have mentioned about CF. We have mentioned about BC and this angle C, this full angle C. This full angle C. So side, angle, side, SAS. In the second triangle, we have mentioned about, see, this is the second triangle. Take away this one. Don't see this line. This is the EBC. This is the second triangle, EBC. Don't see this line, the EBC. This is the triangle. We have mentioned about EB, BC, and this angle B, this full angle B. So again, side, angle, side. So by SAS congruence rule, the two triangles are congruent to each other. And when you use these two triangles, this triangle which has EC and this triangle which has BF. Okay, then see, it's like this. It's like this. Yeah, like this, something like this. And okay, so this is ABF. And this is ABF, ACE. All right. So why do we take up these two triangles? Because we have BF here, we have CE here. So if you show that these two triangles are, congruent, then also by CPCTC you will get BF is equal to CE. BF is equal to CE. So here AB is equal to AC given. AB is equal to AC given. Then AF is equal to AE. AF is equal to AE. Because why is AF equal to AE? Because AC is equal to AE. AC is equal to AB. The full sides. AC and AB, they are equal. It's given. AC is equal to AB. So half of AC is equal to half of AB. What is half of AC? Now what should you take? Half of AC? AF. And what about half of AB? AE. AE. That's how you get AF is equal to AE. AF is equal to AE. And angle A is the common angle. You can see like here, like the earlier proof you said BC is the common side. In the earlier proof you said BC is the common side. Both the triangles have BC. Here both the triangles have this angle A. Both the, see here, when you take this triangle and the other triangle and this other triangle, both the triangles have angle A, common angle. A is the common angle. This one is the common angle. A is the common angle. So the information is AB is equal to AC given. AF is equal to AE because AC is equal to AB. Half of AC is equal to half of AB. Half of AC is AF. And half of AB is AE. So that's how we have AF is equal to AE. And angle A is the common angle. So here also it is SAS. By SAS congruence criterion, the two triangles are congruent to each other. Once they're congruent, CP/CTC. The corresponding sides are equal, so you have DF is equal to CE. Yeah, both the proofs are here, children. Take a screenshot. Both the proofs are here. Take a screenshot.
Taken, ma'am.
Yeah, now you need to complete this in your notebook. All right.
Yes, ma'am.
Yes.
Yeah. Now, children, for the rest of the half an hour, I'm going to show you the other proofs. Please finish that. Finish that and share your pictures with me on WhatsApp. For the remaining half an hour, I'm going to share the other slides with you. Take screenshots. Please complete them. We'll understand the proofs in the next class. Yeah, here it goes. See here, I'll tell you about what the triangles here and here. No, this is just for your reference kind of. These two triangles. See, these are like some rough work. When I explain the proofs, you will understand. So you need not draw these two. This is just for me to explain. You don't have to draw these two triangles. Yeah, take a screenshot here also. You need not, if you want, you can draw. You need not, this is just for me to explain. So you need not draw them. So your proof ends here. This one is not needed. Take a screenshot, children.
Taken, ma'am.
Taken, ma'am. Taken,
Yeah.
ma'am.
Taken, ma'am.
I'll let you do.
Taken, ma'am.
Right.
Taken, ma'am.
All right. All right. They're not at all difficult, children. It's easy to understand. You can, try to understand by yourself as much as possible. And then when we do it again in the class, it'll become easy for you. For some, proofs are very easy. It comes very easily. For some, we are good at, number-based questions, but proofs are sort of difficult. So it depends. This one differs from, student to student. Most of us are comfortable with numerical sums. When it comes to proofs, it may look difficult, but actually not. This is easy because everything is given. You just have to arrange the information in a particular order that suits the congruence rule and finish it. That's it. Actually, these are easy. If you show some more interest and more focus, you will definitely, agree that these are more easy than the numerical ones. All information will be given. Everything is given. You just have to identify the correct congruence rule and write the information, the equalities in the correct order. That's all. Taken, children? Screenshot?
Yes, ma'am. Yes,
Okay.
ma'am.
Taken, ma'am.
How many more? Oh, sorry. I finished, I think the 6th one, right? I finished this. Yeah, this is the 6th one.
Taken, ma'am.
Taken,
No, I
ma'am.
think so much you cannot finish now. I'll give you time till tomorrow afternoon. By 4 o'clock tomorrow, all of you should submit this work. By 4 tomorrow, all of you please submit this work.
Taken, ma'am.
All right. Okay, children. So after this, we only have exercise 7.3. And after that, we will be doing extra proofs from congruent triangles, not from NCRT, outside NCRT. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you.
Thank you, children. Thank you.